People come from monkeys. That's gotta be one of the biggest lies ever told in the history of biology. You see, a few years ago, Charles Darwin proved this theory wrong by saying that all of us come from the same common ancestor. That is, cockroaches, snakes, human beings, all of us share an aspect of our DNA. So, what makes us different from everybody else? And above everything else, what made humankind, Homo sapiens sapiens, which is you if you're unaware, become the most dominant species on planet Earth? Was it because of the thumb, which allows us to have more precision and more grip? Was it because of the bipedal walk, which freed our hands to carry tools and walk around? Or was it because of gossip, which is at the center of bonding human groups? Well, even though gossiping about your boss or about your friends may seem extremely fun, there is one specific ability of Homo sapiens sapiens that seems to outweigh every single thing that I said, and that is the frontal cortex, which is located right in the front of your brain, which gives us the ability to reason. I got extremely interested in this subject, so I started searching deeper and deeper, and I found something extremely interesting. Even though every single human shares the same anatomical structures, the same CPUs, so we all have a brainstem for breathing and other functions, we all have a cerebellum for motor control, at the same time, we all work differently. We all function differently. And there was a specific subset of brains that caught my attention, and those were neurodivergent brains. So, for those that are unaware, neurodiversity is the concept of people that have certain neurological conditions that hardens their learning, their socialization, and other skills. But I found something that could help these people, that include people that have ADHD, autism, and other things. If you include social-emotional learning as a part of the curriculum, if you teach these ideas that are going to immerse them into society, it's going to be easier to create the future leaders of tomorrow. So, I created a project called Mercenary Corporation, which is now called Saga, which is an enterprise that aims to develop products and platforms that uses AI, other language learning models, technology, computers, to develop social-emotional learning skills in children. And there was one thing in specific that we really like to do, which is getting feedback from our customers so we can increase customer experience and make sure that our goals are being extremely fulfilled. So we work with parents, teachers, students, and in a certain day, we were receiving feedback from a specific parent. And he asked me a question that completely caught me off guard, and I had no idea how to answer, which was a question that actually inspired this TED Talk. He told me, Henrique, our growing reliance on technology and its development is, even though it's good, such as your platform, because it's something that works, is compromising certain abilities in kids. So I would like to ask you, will we lose the ability to reason? I was a little bit shocked by this question because as a neuroscience enthusiast, I thought that the frontal cortex ability to reason was unmatched, and there couldn't be a single thing on Earth that could match this capability. So, what is reason anyway? It can be a variety of concepts. We can talk about philosophy. So we had Aristotle, who said that reason is the contemplation of metaphysics, and that's going to be the end goal of man. We also have Kant trying to define reason, trying to understand its limits and what exists beyond this limit. However, for the purpose of this TED Talk, we will talk about reason, not in the sense of what gives reasons for us to do something. For example, I'm hungry, therefore I'm going to go to the supermarket. We're talking about reason in the sense of engaging with the faculty of reason. And that means using acquired knowledge to draw inferences and therefore propose a solution. So, for example, if you know that A equals to B, you can infer that 2A equals to 2B. You can go even further and assume that 3A equals to 3B. And then you can propose a solution. 2A equals to 2B minus C, minus 5C. But I'm sure that everybody else thought that A equals to whatever that is, right? So that's how the frontal cortex works. acquire knowledge, drawing inferences, and proposing a solution. And that has been the biggest driver of societal progress for years now. Let's take, for example, the agricultural revolution. Somebody at a certain day learned that if you plant a seed on the ground, it's going to grow. And with that, you can harvest, you can feed your animals, you can even feed yourself. So I just learned this. Therefore, I don't have to move households every 3 months. I can just stay where I am and save energy. And that's what we did. And this ability of the frontal cortex can be reduced to a simple equation. Demand plus knowledge equals to innovation. And that was unmatched for centuries. Nonetheless, in 1936, the biggest and the first rival of the frontal cortex finally emerged in a revolution that was known as computer revolution, or even the silent revolution. In 1936, Alan Turing published a paper called Uncomputable Numbers, in which he introduced computers and its ability. And as computers developed, we found something with a higher processing power. So we have GPUs and CPUs that can process over 200 billion informations per second. So we found something that is extremely more efficient than the human brain itself, right? So if we have something more powerful, something more magnificent that can draw information much faster than the human brain, why are we going to reason? If we can just find information on Google or ChatGPT, there's no reason to use our frontal cortex for nothing anymore. And that's exactly what has been happening. So in a study published in Science, Sparrow, Liu, and others, they discovered that people, they are more likely to retrieve not the information, but where they can find information. So for example, instead of knowing that Warsaw is the capital of Poland, you know that Google has the answer. So you Google that information. And that came to be known as the Google effect. So, I ask you, will we lose the ability to reason? Based on what I have presented to you, the response is likely a yes. We are going to lose the ability to reason. However, there are a few aspects that we forgot to take into consideration. If we are proposing that something created by the human brain can be more powerful than the human brain itself, that's counterintuitive. That's a backlash. There is this theorem called incompleteness theorem that states that a system cannot create a subsystem that is more powerful than the system itself. That is, X cannot create H, can create H, but H can never be more powerful than X. And there's also one thing that we forgot to take into consideration. The brain is not a computational system. The brain is a biological system. This means that the brain does not work by bits, binary numbers, +1, -1, 0, and information running around. It's about your interaction with the environment. Remember what I said earlier. We all have the same CPU, but somehow we are all different. And that is called a complex system. The brain draws inferences, the memories, the good, the bad ones, to reach a certain result. And that's what leads to brain diversity. Therefore, if you tell a computer that 2a equals to 2b, it's never going to assume that 2a equals to 2b minus 5c unless you tell the computer that that's true. And there's also something else. We didn't mention the incredible capability of the brain to transform and to heal itself based on need, based on necessity. I'm talking about people that have had strokes and lost the movements of the entire right part of their body and still regained after practice, after session, after each time learning more and more. That's something that computers cannot do. For example, Dr. Edward Taub proved this concept when he found that if you injured a monkey's arm without causing any nerve damage or any spine damage, the only way in which you can make this monkey regain its control of the other arm is if you injure the other arm in the same way. Because haunted by a need to survive, the brain is going to adapt. The brain is going to be plastic, which is exactly what I'm talking about. Demand of using the arms, knowledge on how to use the arm because he knew how to use the other uninjured arm, led the innovation on how to use the arms. So I ask you again, will we lose the ability to reason? Exactly. I don't think so either. So you use acquired knowledge, you interacted with the environment, you interacted with a different brain, aka me, and you reached a conclusion to understand that we are not going to lose our ability to reason. The frontal cortex has won. Thank you.